They're all on YouTube
Well, that's nice.
and all listed on our wiki. Now we have this spinning gray box of death. I even have
As
slides.
per usual, it is telling me that I'm already being recorded. So,
Oh, okay. Well, I
So
am not yet, so that means I can say anything. Oh, now I'm being recorded. Okay. So let me pop up some slides here. And I will say good morning. There we go. I will say good morning, everybody. Welcome to the official CentOS Automotive SIG meeting for May 2022. I am your host, Jeff Rowe, and we have a quick agenda. Mostly what we're going to be doing today is just the technical status update, which Pierre very thankfully sent around earlier this week, yesterday, I think, or Monday. And then we'll just open it up for discussion. One of the discussion points that I did hear go by was about hardware availability. And I actually had a question about hardware availability. So I'm going to make a note to remind myself to ask about that. Or actually two questions, but we'll get there when we get there. In the meantime, does anybody have any agenda items they would like to throw in? Anything else you'd like to discuss while we're here? Hear anything at the moment? So let's just go ahead and dive in. Pierre, I may turn it over to you. Uh, this is just a summary of what you had put into the message yesterday, but I think it'd be good to go over it in the meeting here on video so people can see it, if that
Sure.
works.
I also went through the last few Automotive SIG's weekly update that we're sending to the Automotive SIG mailing list to pick up some of the points of what we worked on. So I'm looking if I have anything in there that is yeah. So I think we mostly override. So there is I'll start with your slide then.
Sure.
When you build an image and you flash it onto the SD card, it's not going to use the full size of the SD card. The image is about 7 to 8 gigs in general. So if you have an SD card that is about 32 gigs or 128, you're still only going to use 7 or 8 gigs. So that's potentially problematic. If you just want to boot the systems and look around, that's fine. There is no issue there. But if you want to use that Raspberry Pi to build other images quickly, you'll run into disk issues. So we've started with documenting how to manually resize the slash partition on the Raspberry Pi. So that's the documentation that Jeffro is showing here, which is available on sig.centos.org/automotive. And that's step one. But the one thing that we are working on this week, and that will be I'm basically giving a preview to the email on Friday, is that we have a way to make this automatic. So we are going to change all the images that are built targeting Raspberry Pi, so that they automatically resize the boot partition upon first boot. So that would basically make this documentation not needed anymore, not outdated, but not needed anymore, and that should be happening automatically now, or at least once by the end of the week. I have good hope that will be good. The other question is another thing that we have worked on the last few weeks is how do I create a manifest? How do I create an image definition file that I can customize? So there are two ways to do that. One way is to look at the distro file, and that's the way we have currently documented in the documentation. So if you go to customizing images in the documentation, you'll see something that goes about distro files, and that allows you to basically override any of the variables. But if you want to go more than just overriding of some of the variables, you will need to create an image file, and it's you can keep that in your Git clone, but you may also want to track this in a separate Git clone. So we have added a way to interact with the Makefile in such a way that you can point to the image directory of another in another location in another repo. So if you look at the the Git repo, let me put a link in the chat here. you have an image directory, and sorry, I need to go one level down. So this is the correct link in the chat here. You have an images directory, which has a number of images. You can add files in there, and they will be automatically picked up by the Makefile. But you can also keep these files in a different repo, in a different place, not in your Git clone here. And then you can still use the Makefile to build the images, all the benefits of all the infrastructure that we have set up around these recipes, but still giving you the ability to customize it. That is something that we still need to document a little bit more as well. There is one thing as well, it's about the EFI runtime services. So the way it was coded in the Linux kernel was that when you enabled the real-time patch, on the kernel, it would automatically disable the EFI runtime services, and there was no way to turn them back on. So a change that had been pushed in our kernel was there is an extra configuration key that you can use that will enable the EFI runtime services. If you turn on the RT patches, it will be disabled by default, but you can go ahead and turn it on if you know what you're doing or if you really need them. So we actually went ahead because we believe that this is something of interest, and we have enabled the EFI runtime services in our RT kernel. So that's something you can already use today and benefit from. A little bit in the same question, the next one is about naming the name of the images. So if you can build images in the documentation that Jifro linked to, customizing images, the link that Jifro looked at earlier, you can specify, you can override some of the variable via the command line. So you run make developer image, and then you have in the extra RPMs, for example, here that pulls in GDB. This is great, except that the image name that you get as the output is going to be the name of the file, which means you're building this developer OS3 image, and you get a developer OS3 image. Okay, great. How do I know how do I keep track that this is the OS3 image that has GDB installed? Well, you can't or you couldn't because there was no way to customize the name. So we've added the ability to use the @ sign in the file name, and then the @ sign is preserved in the output name, and that gives you basically a way to tag or to give extra information about the image name. And then you have you can have two different names for the image that is the stock developer OS3 image, or the OS3, the developer OS3 image with some of the customization that you have made. So it basically gives you a way to customize the output name of the image created. Back on the slide, I forgot what's the next step what's the next point there. The Lucasite cache structure on CentOS. So this is something that that is less about building images, but more about how we integrate with the CentOS build system. And the way the way CentOS Linux was built is that we have one place that is used for Red Hat to push the RPMs, the sources of the RPMs that are used to build RHEL, as well as a place where SIGs can build on the top of CentOS, be that CentOS Linux back in the days or CentOS Stream for the more recent SIGs. This has led to a number of restrictions in the way that, for example, the Git, it's the same Git repositories for the SIG and for Red Hat, so there needs to be strong enforcement about the Git branching structure, so that the SIGs can only push to the branch that they have access to, and they cannot push to things to the C8 branch or the C9 branch, which is the prerogative of Red Hat. Only Red Hat is allowed to push to this branch. That branching structure was also found in the Lucasite cache. There was mapping, basically, when you uploaded a tarball to the Lucasite cache, it was taking into account the Git branch in the URL generated. But we are giving SIGs the opportunity to move to GitLab for their work, which gives them a lot greater flexibility, a lot more flexibility. But if we still enforce that branching structure on GitLab, because the Lucasite cache was using that structure, It makes little sense. So what we did is that we worked with the CentOS infrastructure team, and we came up with a new endpoint. So if you're an existing SIG and you don't want to change anything, you can just keep the way it is. It's fully backward compatible. The old scripts work, the old endpoints work. There is nothing to change. But if you do want to use the new structure, there is a new upload script. There's a new leukocyte uploads endpoint, and that will use the same leukocyte structure as the one that is used in Fedora or in CentOS Stream. And that structure gives it no longer relies on the Git branch name, which means on GitLab you have the flexibility of using any branching structure that you'd like in your Git repository. So that just gives us a lot more flexibility in there. It also makes it trivial to backport a build from Fedora to CentOS Stream. It's basically a matter of creating the repositories on GitLab, pulling things from Fedora, pushing them on GitLab, pulling the sources from the Fedora leukocyte cache and pushing them to the CentOS leukocyte cache, and it will work out of the box. So that's a nice user experience that we've built there. And all of this is documented on the CentOS develop mailing list. That's what Jeffrey was showing. What's in the next point is we have sample images in autosd.sig.centos.org. I don't know if we are ready with these yet. There was work in progress. They were close to being there. I do not know if they are entirely there yet. I believe so. Yes, we do have now. So I'll put the link in the chat here. You want to go at the bottom to the latest folder, and you'll have sample images. So those are QEMU minimal image using OS3, QEMU QA image using OS2, and RPI4 minimal image that is not using OS3. It's a regular image. So if you're interested to get a minimal Raspberry Pi 4 system, you can directly download this image and flash it onto the SD card and run with it. And that's the place where we will want in the future to publish probably a little bit more images. So
There's documentation
there is
for that
one
too, right? Sorry.
for which one?
I said there's documentation for how to use those images as well.
It's basically you download, decompress, and flash them onto the SD card. It's
okay, so it's very simple.
Yeah. There is one thing that you do not have, and that we've added in the same time is we've added documentation on how to contribute packages. So you have few places where you can contribute packages. It can be in Fedora, it can be in the Automotive SIG repo, or it can be in AutoSD directly. So we've came up with it's in the link is in the chat if you want Jifro. But yeah, it's right there. So Fedora has the added value of giving you a long-time vision to the future. This is what RHEL will be. So this is what the in-vehicle OS will be based on. But any change made in Fedora will take a while before it trickles down to RHEL and to the in-vehicle OS. You can contribute to the Automotive SIG repository. It's very free from here. We don't really have any restriction except for free software licenses. You can send an email to the mailing list or ping us and let us know what you would like to do. We can help you with packaging work. We can help you understanding the different system and how they interact. And then you have the AutoSD part, which is AutoSD being the public in development version of the product. So everything that lands in AutoSD is meant to arrive into the in-vehicle operating system, and so this one it will be a lot more scrutinized when a change is made, because the idea there is that everything that lands in AutoSD will be supported by Red Hat. So there are consequences here about every change made. The Automotive SIG there is a lot more freeform and into what we want to do or what we built for. For example, the Pi resize RPM package that I mentioned earlier, that installs a script and a systemd service that will automatically expand the slash partition upon first boot. That is something that is part of the Automotive SIG RPM repository. It's not something that doubt that Red Hat will want to support this in its product. I don't think that we really want to support the Raspberry Pi in the product, but that's definitely a place where the SIG has added value. And I think that's all I had on your list and on my list. So.
Okay. Yeah. The only other thing on the list, I think, was the namespace change.
Oh yeah, if we haven't mentioned it, yeah, there's definitely. If you have not seen it, we moved from gitlab.com/redhat/automotive to gitlab.com/CentOS/automotive. And the added value here is that we're using the CentOS account system instead of using the Red Hat account system, which means that we can onboard community members who want to contribute to the project.
Yeah, I think that's a great community change. Oh, that was quite a lot of information there. Want to make sure that if anybody's got any questions or comments.
I'd just like to commend the work to sort of
Mhm.
normalize the structure. I know that this is some of that, if you're not intimately familiar with the way that RPMs are built for Fedora and CentOS Stream and whatnot, the details might have been a little bit obscure, but this makes it all a lot more consistent across the board, as Pierre pointed out.
Mhm.
And then the other thing that was really desirable about this, Pierre, is the separation you've made between packages that we view as being bound for Red Hat's product, the in-vehicle OS, having an analog, something very similar to the CentOS Stream model, where even people in the community can make pull requests, but we have the sort of product level control over merging them, but also having a space where we can build packages in the SIG that's fairly open to community members. That's cool. So for example,
Mhm.
if we want to explore the idea of the rough equivalent of a BSP kernel in our universe would be a different kernel RPM that isn't the official kernel RPM. We could do that there. We could have a kernel RPM or multiple kernel RPMs and even supporting packages for boards that aren't yet supported by the mainline or the product kernel. So the groundwork has been laid for doing that now, which is great.
There is one thing that we need to figure out, and I don't currently have the magic. This is how we're going to do that. Is I'm looking for I'm running AutoSD and I want to contribute. Where do I find the sources that I need to look at? Because for most of AutoSD, the sources are going to be coming from CentOS Stream, and for a small fraction, they will be diverging from CentOS Stream, and they will be present in the automotive namespace under CentOS in GitLab here. But the sources that are under GitLab CentOS Automotive could also be sources that are used in the SIG, but not in AutoSD. So, and that's the one aspect is like, if there is, if I'm running AutoSD and I see, what's a good example? I have a kernel issue, and I look at the kernel and I see one kernel in CentOS Stream and I see one kernel in the CentOS Automotive. So is the kernel in CentOS Automotive the one that I'm running in AutoSD, or is that one that is only in the SIG, or is it both? So we need to figure out, and we need to figure out how to point people to the right location when they want to contribute to something. I don't have a good answer for that yet. Maybe just the description of the project on GitLab says that this is AutoSD, or this is the SIG only. So yeah, the Linux firmware is an interesting one. We created a Linux firmware automotive package that is only present in the SIG. We could have this with extras. We could have one in AutoSD that has only the firmware of the board that are supported, and we could have one in the SIG that has more firmware than in the product. If I run one of them, which one should I go? Which one should I go for? And
right.
So those are the things that we will need to collectively figure out as we go. We currently do not have that problem. We may in the future. That's something to keep in mind, and we'll need to figure out a way help people to find the right place to contribute.
I agree. We don't, anyone who's willing to make a suggestion for how to change something at the RPM level, we don't want to lose them because they don't know where to submit it. But at the same, I think it's probably down to documentation and communication. So that's cool. Knowing where will only be the first barrier to them getting the change in is the other thing. We can talk about that.
Yeah, but it's all about lowering those
The
barriers.
documentation should be, are you sure you want to do this? Yes or no? No, I kid. We should be looking at reducing those barriers as well. So,
yeah, always, for sure. Okay. Any questions on any of this? This is a lot to take in, I know. Well, the only other thing that I had on here was hardware availability. We started talking before the recording started about the extreme lack of availability for actual silicon, particularly the Raspberry Pi 4. Seems to be a very rare and precious commodity right now. One alternative that I was going to ask about, Ian is showing us his.
what's it worth to you, Jeffro?
I don't have budget for that.
Name your price.
Yeah, don't have budget for that. One alternative question that I had was about the Pi 400, which is essentially a Raspberry Pi that comes in a keyboard form factor. And I was just wondering, is that actually compatible enough to run Auto? Oh, there, Bruce has one. Is it compatible? Is it something that we could recommend that people use? Is it just a Pi 4 with a different package, or is it actually a different beast altogether?
It's Pi 4 packaged with a keyboard integrated, and interestingly, it comes with the micro HDMI, which is an oddball sort of thing.
Okay.
There are 20 of these at my local micro center. They're about $100. The interesting thing to me was this has an integrated heat spreader inside. So for my regular 4, I need to make sure I go buy a heat sink, or I've got a case that's got the fan in it. I don't like fans on my Raspberries, so this could be the way. There's a site that popped up on Y Combinator recently that was like where to find Raspberry Pis to buy. So there's that as well. And I also got the last Tinker Edge that they had in stock. That's how bad supply chains are. And they had 0 of the actual Raspberry Pis. They haven't had them for months. They said they get them on Wednesdays, and they're gone before they can even put them in the stock. There we go. Yeah, our pilot.
Thank you, Adam. Yeah, that's great. I know that Adafruit had a small quantity not too long ago, I think last week, which I normally do not keep quite the close eye on supply chains, but lately it has been almost comical, except for people who actually need them, in which case it's not comical at all. Anyway, I just wanted to make sure that we covered all the options as far as showing which actual packages you could go to the store and purchase that were compatible with this. And of course, QEMU is also always an option. The other thing that came up, hardware availability wise, the other question that I had, and this is an idle question. Maybe we should turn off the recording. I'm not sure, but the question was about x86 compatibility for AutoSD. Somebody had asked, are we ever going to be building or supplying packages for these for AutoSD with x86? And so that's a question that I will open up to the group and go on mute to hear the answer. Hopefully it isn't just silence after that.
I mean, it's our intention to provide an x86 equivalent. Speaking from the program and the product side, it's clear from a lot of interactions that this actually building and running on x86 is done quite broadly. And as is running on a Raspberry Pi, by the way, at least when they used to be available. So I don't know that we've highlighted it in the SIG because it's much more interesting to contemplate doing it on ARM, but maybe we should look into that as well.
The question came up this was actually a separate community conversation around NUCs, because it's possible to go out and buy an Intel NUC. And obviously the price point is very different from a Raspberry Pi. You're looking at several $100s for a NUC.
That's what you end up paying for a Raspberry Pi right now.
Right. Yeah.
Interestingly.
And
Yes.
so, as those two things become closer, you're like, well, maybe it is something we could consider, at least in a development framework. I don't think anybody would ever seriously put a NUC in a car, but anyway, it was something that came up, so I thought I would bring it up to the group. We always usually have a good time tossing hardware ideas around.
I've connected with embedded teams that have put x86 on maritime and avionics applications. So this thing is very closely aligned to an industrial flavored OS tree loadout that other folks would probably be interested in. And the QEMU aspect, the ability to run a device under test as a VM, is super useful.
Yeah, I'll say that there's not a lot of concern about being able to produce a close x86 equivalent, and I've always highlighted that that's one of the things that may be unfamiliar to people who have used different embedded target OSs in the past, is that there's not a lot of distinction between the devel and build environment and the runtime environment, unlike something like some of the RTOSs where the devel and build environment is an app that runs on x86 and the target environment is some other thing. We don't really have that distinction, and it's essentially trivial for us to produce an x86 equivalent. But if you're building for an ARM target, you need an ARM build environment. And that's why that message coming through, that we're talking to people who are mostly used to the SDK model, and therefore x86 can be their devel environment and build environment, even if the target is ARM. Whereas the tools that we inherit from Fedora and RHEL are based around a different model. So that's why our focus has been on how do we make ARM easy to use, what ARM platforms are available, how can we bridge the two together. Pierre has done some cool work for some interesting ways to literally physically bridge the two together in a way that might be useful. So yeah, but the x86 is not excluded from this by any means. It's just it's not the hard problem, I guess, to put it that way. So.
Certainly. A related question came up from the Fedora side, actually, or from the Fedora community, about RISC-V, because Fedora is Fedora, I believe it's now completely up to date with RISC-V hardware, with at least a couple of different actual pieces of RISC-V hardware that we have in the lab. Is there any intention for us to eventually support RISC-V? Possibly not coming from Red Hat.
Fedora doesn't support it.
Sorry?
Fedora doesn't support it yet either. It's not in the regular build system.
Okay.
It's being built in a like a shadow koji and uploaded.
Oh, okay. Okay.
None of the systems that have been evaluated or looked at meet what we need to be in the main data center.
Okay.
And so they'd have to be in like the Boston lab, and that one's full. So
okay, I'm not sure where the actual hardware lives.
So the actual most of the build hardware for Fedora lives in a lights out data center in outside of Washington D.C. Lights out means that there aren't anybody. It's a major ticket to get somebody in there to reboot systems and such.
Right.
systems should be autonomous and able to handle themselves.
I do remember this discussion. Yes.
And the RISC-V hardware is not at it's beyond prototype, but is not in that level.
Yeah. Ian?
Yeah, and there's clearly a desire as RISC-V matures to bring it into the Fedora ecosystem. I don't know what the roadmap thoughts are on it for server, for example. I think it's an interesting one in that it seems likely to be something that will never, it's not really being targeted at that, which gets right back actually to the build and SDK environment. If there's not really going to be server class hardware running RISC-V, then that is a challenge for the way that we've typically chosen to build things. But
there is
so
one, there is one company that's creating server class RISC-V
Hmm.
hardware now. I believe they have 1,100 cores on one board.
Yeah, but like, if we restrict our discussion to, we're focusing on Auto SD. This SIG is not actually. I mean, look. I believe many of the people joining are Fedora users, often Fedora Silverblue users. It's not like we're not aware of it or don't want it, but it's been a conscious decision to focus the SIGs on, at least Red Hat's contribution to this SIG, on things that are more targeted at a derivative of RHEL. So, and there's not, I don't know when RISC-V is on the roadmap for RHEL. It's not right now, but
it's not on the visible roadmap for sure. Yeah. Okay. That one was just my personal.
No, I mean, having said that, every time I see one of these, I'm tempted to get something. I have more single board computers than I should. Especially now, I should spread the, like Bruce does too. I know he's not.
Yeah. Yeah.
You said there were 10 of those Raspberry Pis left at Micro Center after you departed, Bruce. How many were there before you arrived?
There were 22, and then when I left, there were 21 because they had a policy of one per customer.
I've seen this, yes.
Yeah.
Like, yeah. Okay. So yeah, I don't keep bringing it up, Jeffro. I think it's cool.
One of the reasons why I'm bringing it up is because there's an ongoing discussion within the RISC-V community. For those who don't know, I was deeply involved with RISC-V for a couple of years over the last few years, and there's been a discussion going on in the community about automotive hardware and what are the requirements. Now, granted, the RISC-V community is all about the RISC-V instruction set architecture. It's not about actual hardware. It is the hardware vendors who are part of this discussion. So they're listening to hear what kinds of features could show up in the instruction set that would be of interest to automotive. And then, how does that translate into actual physical features, components on the board, etc. So there will likely be an automotive discussion group starting up within the RISC-V community this year. And I thought it would be fun to bring Auto SD to it and say, here's something that we could potentially run. If somebody has a QEMU setup or some other kind of maybe on an FPGA, a core that we could load up, and let's go ahead and run it and see what we can see if there's a way to dynamically co-develop these two things. This is obviously outside of the realm of what's interesting to Red Hat using Auto SD as an upstream for a product called the Red Hat in-vehicle operating system. Yes, yeah.
No, I mean, I guess I'll ask a pointed question about this. Like, and this is, I don't have skin in this game, but what is the presumed benefit of RISC-V over smaller footprint ARM-based SOCs? Is it purely the open nature of the instruction? Don't even want to poison the discussion. Like, what is the expected role that it would play relative to a similar ARM RISC-based system that is smaller than some of the ones we've been looking at right now?
The main benefit of RISC-V is because it is open, it is completely customizable by the user. So you can literally go out and just design your own cores and deploy them. It is not something where you need to have a license or follow any kind of a guideline. So it's basically Wild West. And while that is, can be beneficial in some ways, it can also, sometimes those limits are there for a reason.
I can see the automotive people, once they realize that, seeing at first going, "Oh yeah, yeah, yeah," and then realizing, "Oh
Yeah.
crap."
suddenly, suddenly I have to become a hardware engineer.
Well, not just
And
a
that's,
hardware engineer, but there's a lot of liability and such that goes
yeah,
to somebody else's pocket, and all of a sudden it's on mine.
yes. Yeah. Becoming a fabless semiconductor is a non-trivial task.
It's been
And
said that the ability to rapidly integrate IP as provided by ARM allows those fabless companies to get things together into the core plus the whole elements that make the SoC,
mhm,
and get support from ARM, whereas PowerPC could not make that conversion with PowerQuick because although they had a lot of flexible and very interesting little blocks, they couldn't bring the whole picture.
mhm,
So it's interesting to see RISC-V basically take an open source stab at the same kind of situation.
mhm. Yeah, and I wondered why open power didn't proliferate in that same way, given that it's also an open ISA. But anyway, it's interesting to watch. It's obviously it's not directly on our radar as the automotive SIG, but
Not yet.
not
Yeah.
yet. But I think it probably could be it probably will come up, over the next year. And it is very fun to watch the disruption within within the market. I'm actually much more optimistic about in the ARM world about Sophie and the reference architecture that's being developed specifically for embedded and automotive applications. I think it's going to be very popular as the sort of system ready for automotive. So it is
That,
18 minutes until the top of the hour. Does anybody have anything else they want to discuss? Because we could probably just yammer about hardware for the rest of the day.
the one thing about the risk work would be if we wanted to look at this, in 6 months from now, we would we would have to do a bunch of the work of porting.
Mm.
Basically, we would not be able to leverage CentOS Stream.
Mm-hmm.
So if CentOS Stream was ported to RISC-V, then we would automatically inherit from that, and we would only have to care about the part where we diverge from CentOS Stream. But if it's as long as CentOS Stream doesn't support RISC-V, then that makes it you know another level of work
Sure.
to be able to experiment with that.
And it's possible that somebody will contribute that work. It may or may not come from us.
Okay.
It may or may not come from this particular SIG.
That's right.
Yeah, I believe there was a 32-bit ARM recompile of CentOS 8, even though
32-bit?
that wasn't. I thought so. Maybe I'm misremembering.
Hmm.
Or maybe it was RHEL 7 even, CentOS 7, I should say. But
Yeah.
yeah, I have no insider information on this, but I consider it unlikely that RISC-V would be added as a supported architecture in the lifetime of RHEL 9. But
Mm-hmm.
it's not unprecedented for the CentOS community to experiment with that.
Yeah, there was somebody who was doing work for both x86 32 and ARch 64 32. They ran their own builders for a while in the some of the CentOS hardware.
Yeah, that might be what I'm thinking about.
They ran it as a separate group, and then they once CentOS 8 was gone, there wasn't their interest in doing so, continuing it was gone too.
Mm-hmm. Yeah. Okay. Well, do we have any other action items or discussion topics for today? Because if not, then maybe I'll give everybody 15 minutes back and we can continue our hardware musings in the office hours in a couple of weeks.
Sounds good to me, Jeff. Thank you.
All right. Sounds good. All right. Well, thank you everybody for joining. Really appreciate the update, Pierre, and congratulations on a very large amount of work done over this last month. And we'll talk to you all soon.
Thanks, April. Bye-bye.
Take care. Have a great day.
everyone.
Cheers.